This video is included in Unit 1. It's going to cover Learning Target 5, which is our learning target on writing equations of linear functions. So how do you write a linear function given 2 points? So ultimately that's the goal, is to answer that question. We're going to talk about other little bits and pieces along the way, but we want to get to the point where we're just given any 2 random points and we can create a linear function or a linear equation using those 2. Let's recap the different kinds of ways we can write those functions. One way is in standard form. Standard form works like this: ax plus by equals c. The a, the b, and the c will be numbers. The x and the y are always in every single function, every single equation. An example could be something like 3x minus 2y equals 6. The 3x is the part where it says ax, the negative 2y is for the by, and the c is a 6. So a is 3, b is negative 2, and c is 6. Another way we can write an equation is in point-slope form, often used to just help us create equations. Not so often left in this form, but it is one way to write out a linear equation. An example of what this looks like might be y minus 2 equals 3 times x plus 1. In this way, we see that the m, which always stands for slope, is the 3. And our points are the x1 and the y1, the 1 and the 2. So again, m is slope, and this is part of our point. And the y is also a part of our point. Now it's important to know that in this problem, this little example right now, the x, there's usually a minus sign after it, but in our example there is a plus sign. So because of that, the number that had to have gone into this x1 spot changed this sign from negative into positive, meaning that the x1 is not a positive one, it's actually a negative one. But the y1 where the 2 is, its minus sign didn't change. So no negative was plugged into this spot. So it's actually a positive 2. So keep that in mind as you do problems, that those symbols will always switch, minus, minus. So if there's a plus, it's actually a negative number. And the last way, and one of our most useful forms, is slope-intercept form. Why is it called slope-intercept form? Because the m is the slope, and the b is the y-intercept. And we will use this one a lot, especially when we're trying to graph. So we can look at a graph, use information on the graph to create one of those different forms. So the simplest way to do this type of example would be to identify a y-intercept and the slope, as long as we can. So let's check out what those 2 things might be. We have a y-intercept that is happening right here at positive 1. And we can count a slope by counting rise and run. Our rise is actually a down. So in this problem, I want to go from this point over to this point, because that's the next point along the line that actually hits a good spot on the grid. So we're going to count down 1, 2, run 1, 2, 3. So that's down 2, negative 2, run 3, it's to the right, so it's positive. So our slope is going to be rise, which was -2, and run, which was +3. Slope-intercept form is probably the best way to do this since we have an intercept and a slope. Now the m, remember, is our slope, and the b is our y-intercept. So I'm going to plug in each of those things and I'll have my final answer. Y equals -2/3 x plus our +1. It's very important to know that in this problem we put +1 right here because of the +1 that we got for b. We're not going to put a -1 because it's not a negative y-intercept, it's a positive y-intercept at +1. This is our answer to our question. Y equals -2/3 x plus 1 is the equation that would graph the line for this example. Write the equation of the line that passes through the point and has the following slope. So we're given a slope, we're given a point. The point, though, is not a y-intercept. In this problem, I cannot use slope-intercept form. I can't use y equals mx plus b to start myself out because I don't know my b. B is a y-intercept. 2, 1 is not a y-intercept. We're going to have to use the other form, point slope form. So let's write that down. Point slope form is y minus y1. y1 is the y from the point, from the coordinate, equals m is the slope, times x minus x1. x1 is found in the coordinate that's given. So it's just a matter of plugging in each of these pieces. My slope number is going to get plugged into the m spot, and my 2 will get plugged into the x1 spot, and the 1 will get plugged into the y1 spot. Let's replace each of those numbers. So now it's y minus 1. I don't put +1. I know it's a +1 in the coordinate, but remember the formula already has a minus sign. We don't change that into a plus unless we're bringing another negative because 2 negatives make a positive. So y minus 1 equals -1/2, there's the slope plugged in, times x minus x1, which is 2. I want to take this a couple steps further and really simplify this equation down to something nice and simple like slope-intercept form. To do that, we're going to have to get rid of the parentheses. Let's distribute the -1/2 into the x and the -2. This gives me -1/2 x. And what is half of 2? Half of 2 is 1. And a negative times a negative is a positive. Rewrite the y minus 1. And the last thing to do is to get the y by itself for y equals mx plus b. So we're going to have to add the 1 to the other side. My simplified answer is -1/2 x plus 2. Remember that what we started with was called point slope form. We used it because that was the information given to us. We ended in slope-intercept form because it's a lot simpler and easier to use. Moving forward, we're going to have to remember that sometimes we have to create our slope ourselves. We're not always given a slope. When we're given 2 coordinates like in this example, we're going to have to use both the definition or the formula of slope to create it. Slope is described as the vertical change over the horizontal change. You guys call that rise divided by run. Vertical is y's. Change is found by subtraction. So the formula would be to subtract the y's divided by subtract the x's. We can't do this if there ends up being a 0 on the bottom. So if you end up plugging in numbers and there's a 0 on the bottom, then there is no slope. The slope doesn't even exist. For our examples, we're going to be working with problems where the slope does exist. So let's replace each of these. Let's call this x1 and y1, and call the other point x2 and y2. And let's plug those numbers in. Slope is represented by the letter m. So m is equal to, we're plugging in our y's, the -5 and the 4 into the top part of our formula. -5 minus 4. Now we're going to take our x's, -2 and -3, and they get plugged into the bottom of the formula. -2 minus -3. Notice I have a minus symbol because of the actual slope formula, and a negative because that is what was in the coordinate to begin with. I end up with -9 over, remember, a negative and a negative make this actually plus. So this is -2 plus 3, which is 1. My final answer for my slope is -9. So this is how you find slope. Subtract the y's, subtract the x's, and divide. Write an equation that passes through 2 points. So you see here, I'm not given a slope. I'm not given a y-intercept. We're going to have to create a slope in order to actually finish this problem. That's why it was important to review the slope formula and how to create slope from 2 points. So first is to actually do that. Let's create a slope from these 2 points. Again, let's call this x1 and y1, x2 and y2. M will be equal to, subtract the y's on top, 1 minus 4, subtract the x's on bottom, -3 minus 2. Make sure that they're stacked where they came from. The 1 and the -3 both came from the same point. The 4 and the 2 both came from the same point. Let's see what I get. 1 minus 4 is -3. -3 minus 2 is -5. A negative over a negative is a positive, so my slope is +3 divided by +5. Now you can choose whichever one you want, whichever point you want when you use point slope form. I'm going to go ahead and use this first point in point slope form. One more time, here is point slope form. Y minus y1 equals m times x minus x1. We're not going to plug anything into this y because if we lost it, we wouldn't actually have a problem, an answer in the end for this problem that says y equals. It's this y we're going to plug something into. What's the y in the coordinate? 4. Y minus 4. We got a slope. Let's plug it in. 3 over 5 times, and again, this x, we need x's in our final answer. This x stays, and the x1 is right there, the 2. So minus 2. We're going to go ahead and distribute this out. So we end up with -3 over 5x, because this times x is 3 over 5x. 3 over 5 times 2 would be 3 times 2 is 6 over 5. A positive and a negative make a negative. My last step is to add 4 to both sides so that my final answer ends up being y equals 3 over 5x, and -6 over 5 plus 4 is positive 14 over 5. And there's my final answer. Lastly, we want to be able to create equations while looking at any line, any possible line. All lines are made up of points. If we could identify 2 points, just like we did in the last example, we'd be able to use those same steps. First, I'm going to look and see, do I have a y-intercept? I do have a y-intercept right here, but there's no real good way of knowing exactly where this crosses. It doesn't hit exactly on the grid, so I can't be certain. Maybe it does look like halfway, but I don't really, completely know. So I do identify a couple points. So there's one over here. And as I follow this up, I think I see one more over here. With 2 definite points, I can now count slope. So let's do that. 1, 2, 3. It's a positive 3 rise. 1, 2, 3, 4. It's a positive 4 run. That means I've ended up with a slope of positive 3 over 4. Remember, the rise on top, the run on bottom. Now, in order to use our point slope form, we're going to need to identify one of the points. It doesn't actually matter which one. You just need to use one of them. So I'm going to go ahead and identify this point right here. This point is at -2, 0. Yes, you could use this point as well, but it doesn't matter. So let's plug these into the y1 and the x1 and plug the 3/4 into the m. I end up with an equation that says y minus 0 equals 3/4 times x. Look very closely at this, positive 2 plus 2y. The x I'm using is a -2. When the -2 plugs into this x spot, the negative and the minus sign is 2 negatives to make a positive. Let's wrap up the left side of this. Y minus 0 is just y. And distribute the 3/4 into the x and the 2, giving me 3/4 x plus 6 over 4. Now 6 over 4 is a reducible fraction. We can reduce this fraction, both 6 and 4, down by 2. So let's do that. Divide by 2, and I end up with 3/2. This is my final answer. That covers it for writing equations. Here's examples we talked about. We talked about the different forms. We talked about how to just plug in slope and y-intercepts into slope-intercept form. We talked about how to create slope with slope formula. And we talked about how to use 2 points to create a slope and then use point slope form to plug all that information in. And this example you just saw is very similar. If you haven't done so, go through and chunk your notes so that you know where one example ends and begins. And if you have questions, if anything didn't make sense, don't forget to write that in the left column and be ready to come in and share with your group.